This is number 1 from your homework packet on the day 2 section. All right, look. This time it doesn't just say get in the rectangular form. It says get vertex form. And so you have to get it so it's just x and y, but then go further. So like when I did an example, I just made a table and graphed it. Before we graphed it, by the way, last year I made the mistake of not noting the restriction there before I started graphing. And so the whole graph didn't fit because it was going off screen, so I'll try not to make the same mistake this time. First of all, let's talk about giving vertex form. To combine these to be one equation that's just x and y, first, look, you don't, I guess my point is, you need to realize that you want to take this equation, solve for t, so let's start doing that. Get t over 4 by itself, it's going to equal y plus 5. And then quadruple both sides, and you get 4y plus 20. And then you substitute this in place of t here. And so the other equation has y plus 20 squared plus 3. And you're done. You have a rectangular equation. Now, I say you're done, not with everything into this problem, but I'm saying you've achieved your goal of getting a rectangular equation at least, everything in terms of x and y. One thing I do want to point out is that you could, in theory, solve this one for t, but you wouldn't want to because it's quadratic. And so that's why I chose to solve this one for t and substitute that way. By the way, what kind of parabola are we looking at? One that opens which way? It's horizontal and positive coefficients to the right. Yes. I'll write that down now. Opens to the right. But this is not vertex form. Vertex form, basically, you should have something like this, y minus k parentheses squared with nothing in front of the y. So, now listen. If it was like 4y plus 3 or 4y plus 5 or something like that, what I'm about to show you wouldn't work. But this is a nice example. It has a common factor, right? Now, you got to be careful with this. So I'm going to kind of take it slow. I'm going to rewrite that as that times itself, because it does equal that. And I'm going to factor out the common factor of 4, but you get a common factor of 4 twice, right? So the reality is what you get a 16 times y plus 5 squared. That's a whole lot easier than the alternative. Now, if I go back to the original, you know, if you notice you have a common factor of 4, really, there's a common factor of 4 squared. And you can just pull the 4 out and realize it's a 4 squared. And you can factor it away. I'm okay with that. But most people would just put a 4 and get it wrong. So be careful with that. By the way, the alternative, if this had not had a common factor, you basically have to simplify the whole thing and get what we call general form, which is, we're going to go over this today. But if you get something that's in general form, you have to do the whole complete and square thing, and that's the other alternative. That usually is what you have to do. All right, now listen. Instead, get vertex form. This is an acceptable vertex form. I'm going to accept 2 different vertex forms in these problems. So what I mean is, this is the Algebra 2 vertex form. The pre-cal vertex form should have the 3 over here, and the coefficient should be in front of the unsquared term. So it's a 1/16th when you move it over here. So I'm saying these are both valid answers. I'll take one or the other, okay? And you should be able to go between them very easily. And either way, realize it's a horizontal parabola, opening to the right. Now, let's talk about how you graph this thing. Most of the time, I would say, you're going to be able to use the new form. Now, this coefficient is 4p, and be careful about this. Our form, let me just write this. It looks like this: 4p times x minus h equals y minus k squared. What I'm saying is, if the coefficient is in front of the n squared term, then it represents 4p. If the coefficient was over here, it wouldn't mean the same thing. And so that's a mistake I made yesterday on one of the examples. I caught myself this period, but I redo it first period because the coefficient was originally over here and I forgot to move it over here first. So anyway, be careful. So yeah, it's really tiny. If 4p is 1/16th, then p is a fourth of that, which is a 64th. We're not doing that. But let's do the vertex right. Looking at this, the vertex is positive 3, negative 5, yes? Look at the other form. You see that it's what you did in Algebra 2, except for it's reversed. In other words, what's inside, you do the opposite. So the y value is opposite what you see here. But the x value, you do exactly what you see, which means it's positive 3 for the x value for the vertex. Same idea, but a little different. So put that on, now actually we're not going to put it on the graph yet, because we're going to have to scale the axes. And so, but I do want to point this out. This is your vertex. Where's the focus? 1/64th to the right of that. And I said, no, we're not doing that. And the latus rectum is 1/16th in length. Not useful. We're not doing that. So we're going to use this form and just graph it like you did in Algebra 2. Now, so that means we're going to plot the vertex, and then the first point is normally what, let me say this again. Like, let's say this is the vertex, which is not. If you're going horizontally, then normally you say, okay, if I'm 1 out from the vertex, I'm 1 over. 1 squared is 1. And then if I'm 2 out, I'm 2 squared is 4 over. That's the way you normally would draw a horizontal parabola, exactly like that. Except for ours, those numbers, those y values, okay, not y values, but how far away you went this way, is 16 times as big, right? So the one that's over 1 would now be over 16. The one that's over 4 would now be over 64. Which we're not going to worry about that one. The reality is, before we start plotting this, we should go back and look at our restriction, because I want to see all that on our table, okay? So what I'm actually going to do is use parametrics to get some points. So make a little table, because we're only supposed to draw that part of it. Now, -5 is not going to be pretty. It's just not, because we're going to have to take 1/4 of it. I'm going to put it there. We'll get to it. But I want to do this first. -4 would be nice. If I plug -4 in here, what do I get? 16 plus 3 is 19. Don't forget, when you square negative, you get a positive, right? When you plug in -4 here, 1/4 of that's -1 minus 5, -6. Now, the other nice numbers to plug in are 0 and then 4. If I plug in 0, what do I get? 3, -5, which means it'll be at the vertex at time 0. If I plug in 4, what do I get? -19 comma what? -4. If you plug in positive 4 here, you get 1 minus 5 is -4. Now, so you have a nice little pattern there, but of course in the 5s break it up. Why are we using 5? Well, because we have to, because we need to know where to plot the endpoint. So here, if you plug in 5, you get 28, right? That's where I made a mistake last period. I made a lot of mistakes last period. I just started drawing the parabola, and I only made room for these points, so we'll have a nicely scaled graph this time, better. By the way, what do you get here? Well, if you plug in 5, you get 5/4, which is 1 1/4. So you have to do 1 1/4 minus 5. Okay? Which, here, I'm going to show you something. We're already subtracting 5, bless you, minus 1 1/4. Just watch. So it's 5 0/4, just for the record, right? You can borrow. I mean, you can do this in your head. You should be able to do this in your head. That's good. But if you're ever uncertain, this works. We need to borrow. We have a 0 here. We need to borrow. If I borrow from here, what do I get? 1. But 1 is 4/4, isn't it? So I'm at 4. So basically, this is now 4/4, and 4/4 minus 1/4 is 3/4, and 4 minus 1 is 3, and so you get 3 3/4, which is what you should be able to do just looking at this without writing anything down. I'm just saying you can do that. You can write it down, borrow, all that stuff. The moral of the story, is that we get -3 3/4 for that y value. If I go up here, if I plug in -5 here, I get 28 again. Here, if I plug in -5, I get -1 1/4. Minus 5 is -6 1/4. All right, let's draw this thing. First, we need to figure out how to scale the axes. I guess let's go by 4s. Will that work? We can go by 3s. 2s just isn't enough if we want to fit 28 in the graph, right? So you choose. Go by 3s or go by 4s? 3s, let's try that. So this is 30 now, right? and we're just going to have to do some estimating on it. So, um, the fact of the matter is you don't have to scale the axes the same. We'll scale them the same. No, we're not pretending. We're going to actually grab it. We can do this. All right. What is this point right here? Yeah, 3, 6, 9, right? So actually that part's not bad. 3 comma negative 5 then is right here. And negative 5 will be close to negative 6. So we'll have to do some estimating. There's a vertex. And that is where it's at time equals 0. And we'll just do our best with all these points. That's 9, 12, 15, 18 is here. 19 is just past that. Negative 4. Well, look. I do both these. At 19, I do negative 4 and negative 6. So the middle is right here, negative 5. One point is down at 19, comma negative 6, which is actually on that line. And one point's just above negative 5. Just for the record, this line up here is negative 3, isn't it? So negative 4 is, between negative 5 and between negative 3. Fun. And then 28, comma, these 2 points. Look at where they are. Wait, I messed up somewhere. Oh, this is 3/4, right? I didn't write that down correctly. Okay. They're just a quarter of a unit outside of these points, right? So you go over here to 28 and go slightly out and slightly out here. Negative 3 3/4 will be slightly below the negative 3 line. There you go. There's our points. And now we draw the parabola. And it stops. Once again, if you're given restrictions, then do not draw arrows because it doesn't go on forever. But which of these points was at negative, where t equals negative 5? The top or the bottom? The bottom one, right? Because the top at t equals 5, you're at the top. So basically it tells you that's your direction along this curve. Now, before we finish the notes, I want you to type these equations in your calculator. Now, if you want to do that, you have to be in parametric mode. How do you think you do that? Hit mode and change it into parametrics. Hold on, no, go away. Listen, so hit mode, change to parametrics. That, the same place we used to change to polar, there's an option to change to parametrics. Go to y equals, and you can just type these in. Watch this. So like I said, mode, come down here, change to parametrics. One thing I want you to appreciate and understand is, look, there's 4 modes: function mode, parametric mode, polar mode, and sequence mode. Look at the button where you normally get x. It goes x, t, theta, n. Different letter, different variable for each mode. So function mode, that's y equals x mode, you get an x. Parametric mode, you're going to get a t when you press that button. Polar mode, you got a theta. Sequence mode, you get an n. Okay, so here, hit y equals, and type in the equations that we're doing. So just x equals, and just press t squared plus 3. And t divided by 4 minus 5. Once you type in equations, hit window. And for t min and t max, I'm thinking negative 5 to 5 would make sense. Okay? For t step, something like that. 0.1, 0.2 is probably okay. And then you can look at our graph. For x min, I'm just going to go from 0 to 30 just like I had in my graph. And y min, I'm just going to do negative 10 to 0 because the whole parabola was there. And there you go. Of course, if I scaled it like my paper, you could also do that. Make it go from negative 30 to 30 there, or negative 30 to 30 there. And it should look like what you have in the paper. Kind of hard to read. Now, watch this. Actually, let me change the window back to something where we can actually see this thing. Now, if you go to y equals, and you can do this with any graph, you don't have to be parametric. So if you put your cursor over here, cursor left, to highlight that. Press enter, you can make it darker. Press enter again, you can make it so you can trace. So if I graph this time, it traces as it goes. Now, let's see. Don't change yours. I want to show you something. All right, give me a second to get it typed in again. All right, now, if the first graph now, I would see it trace one and then trace the other, one after another. I don't want that. I want to do a race. So I got to find that. I think if you go to, well, maybe it's mode. Yeah, there you go. You come down here, you change sequential mode to simultaneous mode. Then if you have multiple graphs, it'll graph them all simultaneously. So, all right, let's see what happens. Actually, let's do this. Do that. Okay. Graph. Okay, is it really not going to make a difference? Oh, there it goes. It's kind of funny. And that's what I was trying to explain to you. Is I have two different sets of parametric equations for the same graph, although the limits have to be adjusted. It's going from negative 5 to 5 in both of them, and the one where I made cubed made it go farther than the other one. But anyways, the idea is it's moving farther on the t cubed one. Which, by the way, I didn't realize it. It didn't occur to me until now. But like here, watch. All you're seeing right now, actually, is the original version. The one where I replaced with t cubed, it's off the screen, way over on the right. And so you keep going. It just came onto the screen. It's going really fast. It's going, I don't know, 25 or 125 times as fast. I mean, it's going much faster. It's also going farther, is what I'm saying. So it goes off the screen, whereas this one's going to, when it's done, this one stops here, and the other one stopped, like I said, way off the screen, way over at 125. And so, what did I do, by the way? All I did is replace t with t cubed, and kept everything else outside of that the same. And so, I'm not getting into that now, but I just want to show you that. All right, listen. So, take out your notes when you finish those now. Let me just say, the test is a non-calculator test. This is all non-calculator stuff. So you can have the calculators out. You can check your work now on the parametrics. That's why I showed you that. You have time, you can play around with the parametrics, because it's fun. I think it's fun. Look back here real quick. I need you to understand, we've been spending these 3 days on parabolas, okay? And then we do ellipses and circles in one unit, which frankly, they're very closely related, and they're easier, so we spend 3 days on the two of those. Then we do hyperbolas, you're going to have 4 different shapes, each with their own equation, standard graphing form equation, or own vertex. Well, you can't call it vertex form. They don't have. Anyway, they have their own parametric equations, and so it's a lot. What's my point? I would try to have this all done, this first packet done, by tomorrow. I'm not taking for a grade tomorrow, but tomorrow we start something new, and you want to know this original stuff before you start the new stuff. And same thing when we get to the ellipses. Get on that and learn it, get it down pat before we get to hyperbolas, okay? I'm just telling you. Otherwise, come test time, you're not going to keep it straight. It'll just be a wash. The whole test will be, you'll get to there, and you won't be able to keep it straight. I need to look at that up. We will have assessments, 2 assessments. I was putting just the units, and I can't remember if we had one during this time frame. I'll look it up again. All right, look up here. This is on the note sheet from yesterday. Find this. Listen. First of all, it says get in form. That's this. When I say standard form, I like calling it standard graphing form. It's basically the form where you can see the information you need to graph it. Like in this case, the vertex. So you can call it vertex form for a parabola. Is this going to be a horizontal or vertical parabola? You see that it's y is not squared, x is squared, so it will end up being a y equals x squared or vertical parabola. You should know that at the beginning. You need to know that because that means you're trying to match this form. Write this down. Your form for a vertical parabola looks like this. It's when you rearrange this thing in that form. Say again? Oh, yeah. Boundaries, right. Now, I'm going to do 2 things. I'm going to move the y over here. It becomes positive y. Then I'm going to swap the whole thing around. In other words, I'm just going to put the y minus 18 on the left side of the equation. I'm going to put the x squared minus 8x on the right side. And so, like I said, I move the y away, but then I just flip the equation around. And then we need to complete the square. This needs to be of the form x minus something squared. It'll be x minus what squared? 4. You take half of b, it's 4. Squared is 16. So we need 16 there, which we also add over here. And then that's y minus 2, obviously. Now, the coefficient was 1. I mean, there was no coefficient. If you want to, write it with a 1 out there so you can explicitly see the coefficient. You can. We normally wouldn't, of course. And actually, if the question was, what is the equation? I don't want to see that. I just want to see y minus 2. But that means 4p is 1, and that means p is 1/4. So here's the deal. And let's get the graph drawn. We're supposed to find standard form. Once again, this was standard form. The other way to draw it, if you ignore these parentheses, move the 2 over, then the algebra 2 way right in the equation would look like this, right? And frankly, this is one where you can take either approach. I'm going to use both. So if I do it the pre-cal way, first of all, where's the vertex? Positive 4, comma positive 2. And so if you look at the algebra 2 equation, you should also get that it's positive 4 for the x, positive 2 for the y. Okay? So plot that. That's here. And then if I want to use the focus and influence the lattice rectum, then first of all, the focus is this distance. Which direction? Well, we said it's opening up. So we're going to want 1/4 unit above the vertex. So it's a 4, 2 1/4. So you put a point just a 1/4 unit here, which isn't wonderful, but it's not too bad. And then you should be able to find the length of the lattice rectum, which is 4p. Really, I'm going to say it's absolute value of 4p. Since I said I'll let p be negative, but this really is just a length. Well, it's going to be 1. If p is a 1/4, then 4p is 1. So we're going to go half at either direction. So half unit this direction, plot a point. Half unit this direction, plot a point. And you have points in the parabola. Now that's not too bad, actually. like I said, that's not wonderful. That's not too bad. You could use that. Let's go the algebra 2 way. If the coefficient's 1, then all you do is from the vertex, so 1 squared is 1, plot a point, either side. 2 squared is 4. And so I'm saying there's your two options. You know, like I said, use P, find the endpoint, find the focus, find the endpoints of the lattice rectum, and draw your parabola through those points. Or use this form and do the old way, where, like I said, if it's just a normal parabola, you just go 1 squared is 1, 2 squared is 4, and use those points. In this case, I do both. You can use, it's even better. That turned out good for once. All right, we need to finish the rest of the, well, you know, that's for the axis. Well, the axis is that vertical line going through the vertex. What's the equation for that vertical line going through the vertex? Come on, vertical line going through this point. X equals 4. Easy. The directrix is a horizontal line going below. Here, let's draw the directrix, so you can see it. The directrix is going to go right along here. It's a horizontal line going how far below the vertex? A fourth of a unit below. So it's y equals 2 minus a fourth, which is 1 3/4. So here's the middle, right? Well, there's the vertex. The focus is a fourth unit above this point, so its y value is this. The directrix is a fourth unit the other direction, so below, so its y value is this. Of course, this is a point with that y, this is a line at that y value, but that's the relationship. And we're done. By the way, was there anything in this problem talking about parametric equations? No. We weren't given parametric equations. We didn't have right parametric equations, so you don't have to put starting point and direction in your graph. You can't read. You don't have parametric equations to get to do that. Okay? All right. Basic one. Horizontal or vertical? Look, it's y squared. Notice it's ultimately of x equals y squared form. It's going to be a horizontal parabola, which means the form we're after is 4p times x minus h over here, and y minus k squared is over here. That's what we're trying to achieve. And like I said, I'm going to swap, I'll put all the y's together. I'm bringing the 6y over here, move the x away from the y, but then I'm going to flip the whole thing around because I want the y's on the right because I'm going to put a big square on them, and I want the x's on the left. And you can obviously do that all in one step. Just be careful that you don't mess up the signs. And then we complete the square here. It ends up being y plus what squared? 3, half of 6 is 3. Squared is 9 to complete the square. So not plus 9 there, plus 9 there. The left side becomes negative 16x. That's what I just did. Negative 16x plus 64. What now? We're not quite there. Exactly. And listen, you're right. I just want to make this little point. You only factor out, when you factor out a common factor, really you factor out the number. You only factor out a negative sign if the lead coefficient is negative. That's the only time. Okay, by the way, what goes inside? Not plus. Be very careful about that. People get that sign wrong all the time. All right, there's our standard form. And this is usable because if 4p is 16, or negative 16, I mean, that means p is negative 4. And let me say again, always in the past I consider p this to be a distance, and I'm changing that. I'm going to say it's how you get from the vertex to the focus. Well, this is horizontal, p is negative, it means you're going to the left 4, right? And that just writing it down here will help you get the direction correct. All right, the vertex, we need to write this stuff down. We're going to write all this down without the graph this time. The vertex is where? Which direction am I going to get to the focus? How far to the left? So where is the focus? 0. Good. By the way, what line are these 2 points on? y equals -3, right? That's your clue that the axis is y equals -3. Also realize it's a horizontal parabola, and, on that axis. So the axis should be horizontal. And then the directrix, it should be 4 away, the opposite direction as the focus was. And it should be a vertical line. The direction is always perpendicular to the axis. It should be at x equals what? 8. Because you go 4 to the right of it, 4. To the right of where the vertex is. Now draw this thing. 4, -3, there. There's your vertex. Go 4 to the left, plot your focus. And 4 to the right, draw your directrix. And then, once again, the focus is how far from the directrix? 8. So if I go 8 away from the focus, I have a point in the parabola because it's equidistant from the focus and the directrix. You don't have to draw the directrix necessarily, but I think it helps remember how this all works. I have to go 8 the other way. By the way, this is it'll be right off the graph. And sketch your parabola. Stop. Oh, good. All right, questions? Look, once again, look, the idea is, first of all, if this is the focus of this directrix, the vertex we know is on the parabola because it's 4 away from each of those. And that's the point. The parabola is all points that are equally distant from the focus and the directrix. So I know I'm saying if I go 8 away from the focus, then I'm going that far because the focus is 8 away. In other words, look, this point's 8 away from that, 8 away from that. Basically what you do is you go 2p this way, 2p this way, and if you do that, then your point is on the parabola because it's 2p away from the directrix, and here you go. All right, one more. Notice this one says parametric form. Okay? Now, we really want, I'd like to have vertex form. Let's get that first. Okay? And so I'm just going to say this is x plus 2 squared. Add 4 to both sides to complete the square, right? So you get y plus 3 equals x plus 2 squared. And actually, what I want is the algebra 2 version. Right, so it's easy. But I say it that way because, remember what I said, the whole real motivation for doing parametric equations is to be able to express your equations, or your equations as functions. And so I'm saying I want to see it written as x equals a function of t and y equals a function of t. So I wouldn't want to see this just rewritten with t replaced. I want to see y equals. And I just lost it. So go and write y equals down here. Same thing, but it would be t plus 2 squared minus 3. All right. I think I'm back. So I'm just substituting. And just say x is t. And you have parametric equations for the same parabola. Now to graph it, we'll just use this. The vertex is at, well, you tell me, where's the vertex? A -2, -3? Is the opposite of what's there and exactly what's there? Chris, you have a question? Exactly. Now, this is easy. If there's normal parabola with coefficient of 1, you just do like I said, 1 squared is 1 on both sides, and 2 squared is 4 on both sides. And let's go one more since we have room. 3 squared is 9. So you go 5 below this. So that is a nice pattern if you never noticed. You go up 1, then 3 more, then 5 more, then 7 more, then 9 more. But there we go. Now, we need to do one more thing because it's parametrics. What do we need to do on our graph? Start point in the direction. So I'll make a little table. You don't have to put it in table form, but you need to calculate these two things. Actually, it's very easy. You don't need any calculations because since x equals t, all you need to do is pick out the points where x is 0, then when x is 1. That would be this point, and then this point, wouldn't it? So you just have the starting point labeled, show the direction, and we're good. I need to find an example where it's backwards, where the flow is backwards.